Hi everyone, thanks for coming. So today I want to talk to you about an overview of candidates OGC Standard for Styles and Symbology, SymCore 2.0, a revision of the current standard that's more focused on the conceptual aspect, but less on implementation. So now we want to focus more on something that people can implement. So I'm Jerome St Louis, founder of Jerry. I'm also the co-chair and the co-editor of OGC Styles and Symbology 2.0. And I'm the lead developer of the Gnosis geospatial software. So we have a map server and a 3D client and a software development kit that implements several of the OGC standards, including most of the OGC APIs. And I'm also a lead developer of the Cherry free and open source software cross-platform software development kit that includes a 2D and 3D graphics engine, a GUI toolkit, an IDE, and a programming language called EC, which is a superset of C with object-oriented features, modules, properties, and it's all compiled in native. It's very similar to Java and C#, but it's compiled in native. So about OGC Styles and Symbology 2.0, so like I mentioned, the focus is really more on implementation compared to the 1.0, and it continues the goals of 1.0, which was SymCore 1.0, which was to revive, modernize the OGC Symbology standard, because before SymCore, and what is still used, because that's the only one that's really implementable, is SLD and SE. So together, SLD and stylable layer descriptor and symbology encoding. And this is how we can describe style sheets at the moment until this is implemented. So basically, I'm here hoping to encourage the open source community to start implementing this draft candidate standard and to provide feedback to the standard working group to make sure this will work and we can achieve our goals. So the big goal really with this is port rail interoperability, and this is reflected in how this is modularized in basically a conceptual foundation, which is not specific to any encoding. Then there's a logical model, which is basically UML that says, oh, these are the classes, these are the properties, and then you can have encodings that can automatically map a logical encoding to how you exchange this in a file format. So the way it's organized, so we have a core requirements class, then we have a basic vector styling requirements class, then a basic coverage styling requirement class. Then there are several other requirements classes for additional functionality. And finally, we have two requirements classes for encoding. One encoding is inspired from the web CSS and several of the other CSS languages that were used in the past for styling cryptography. And then we have another encoding which is based on JSON, which works directly with an existing JSON parser, so you don't have to write parser for it. For the CSS one of my goals at this community sprint this weekend will be to work on the DNF grammar so that you could use a parser generator to also easily parse the ScartoSend CSS encoding. So in the UML diagram here, it kind of showed the high level how this works. So you have basically a style, and a style is 0 or more styling rules. And inside a styling rule, you have a symbolizer, and then that basically says how to style stuff. And then you have a selector that will determine whether the rule is applied or not. So sometimes this is also called a filter. And so one particularity in the SymCore 2.0 is we also have the idea of nested rules. So if a parent rule gets selected, then the nested rules also get looked at. And what this allows is to basically override something. So let's say you want all your roads to be gray, but then let's say if you are at a more detailed zoom level, then you want to change, let's say, from a pixel size to a meter size. So then you have a nested rule that will have as a selector the scale denominator comparison, and then you can override and not change the color, but just change only the width of the stroke. So this is kind of what the nested rules allow you to do. And in the symbolizer here, you can see just only 3 properties, because this is the core, which applies to any kind of data, whether it's coverage or vector. So this is very basic. So we have the visibility, the opacity, and the Z order. We're still working out exactly how the Z ordering will work. There's a lot of trickiness with that. And the other thing is, so you can see in the selector this expression. So the concept of expression is used in two places. It's used in the selector of a styling rule, but it's also used in the parameter value. So that's what those arrows are here, which basically any of the properties you can use an expression to describe it. And then there's, depending on which requirements classes are implemented, some of these are not required to support in core, but as you go into more advanced requirements classes, you can use expressions everywhere, and any type of expressions. This is the, so a quick overview, so it's a bit of a repeat of what I was saying. Conceptual and logical model to encoding, one JSON, one Curves and CSS. We'll have an appendix that says how this maps to SLDSC to facilitate transition from existing implementations that already implement SLDSC. And we'll have a map gallery of use cases that will illustrate what you can describe with this and which requirements classes were used in each of the map. And the focus really is on implementation. So this is really something that will be ready to implement, and it's already, to some extent, ready to implement. And so I hope to engage with some of you at the community sprint this weekend. We had the last community sprint last year in Firenze. We kicked off a lot of this new standard. The latest draft is available here. We have a GitHub repository, so you can submit issues, you can review the progress. So I think I already talked about all of this. Maybe just focus on the target. So the target of the standard is two things. It's either the encodings that can conform to the standard, or it's the renderers, or also the style readers and writers. So the idea is if an encoding fully conforms to some conceptual requirements classes, it means that you will have lossless translation between any encoding that conforms to those requirements classes. So the goal really is for real interoperability, one conceptual model, many encodings. So there's some examples here. If you click here, you'll see some of the examples in JSON and CSS. This is a duplicate slide. So a bit more details into the expressions and the basic type of expressions. We have a literal, an identifier, an instance of a particular class, arrays, and operations. And of course, in an operation, you have one or two operands and then operators. And a special type of identifier is a system identifier expression, and I'll show some examples of that later. In the literals, you can have enums, including booleans, true or false, nulls, integers, reals, text. And then if basically all the elements of an array are literals, then this expression is both a literal and an array. So it's array literal. And the same for an instance expression. If all of the initializing, all of the properties of the instance are initialized with literals, then the whole instance is an instance literal. So these are the system identifiers. So some examples here are to refer to the visualization system scale denominator, the current date and time, the time of the visualization, the type of the data layer. So basically it's a special expression that, for example, for features, the typical expressions refer to the feature properties. For coverage, they typically refer to a field or a band. So here, these are something that refer to something else that is defined by the system. So scale denominator, time of day, current date are the type of things. Or layer type. Layer ID is another example. And the layer ID is a system identifier. So the core operators, we have the logic operators and or not. And we have all the relational operators. That's the logic and the relational. And this is the first example of what the characters in CSS look like. So we have some metadata at the top, title and abstract. And then we have a selector here on the first line. So the hashtag symbol is a shortcut to say layer ID equal land use. And then the selectors all combine as an end. And you can put each selector within a square bracket. So basically this is saying if the layer ID is not used and the type of data layer is vector, then this rule will apply, and the rule is between the curly brackets. Then it sets visibility to false. And then there's a nested rule that says if the scale denominator is smaller than 200,000, and the date is after January 1, 2020, then turn the visibility on, set opacity 0.5, 50%, and Z order is 1. So this is only using the core requirements class. So of course it doesn't do much, but I'll have more detailed examples as we cover a bit more content. So this is getting into how do you style vector data. So first, we add system identifier here, so you can see feature.identifier, so that refers to the feature ID. You can also check the number of geometry dimensions. For example, the 0 is point, 1 is lines, line strings, and multi-line string, and 2 is polygons and multi-polygons. And you can also check if the data layer as a whole has the same geometry dimensions, if it's all a layer of only multi-polygons and polygons, or only line string and multi-line string. So that's the main thing that it adds in terms of the system identifier expressions. Then we add, I'm missing one thing, I skipped this slide. So this slide here is basically, in a symbolizer, this adds 3 properties: the fill, the stroke, and the marker. So that's the main thing that basic vector styling adds. And in the field, you can see here, in this basic vector styling, you have color and opacity, and color is defined, you can specify an RGB or a hex code. And then for the stroke, what's added, so the stroke inherits from stroke styling, because stroke styling is reused for more advanced things, defining stroke casing and stroke center lines. But the stroke also has color and opacity, but it also has a width. And the way the width is specified, there's a unit associated with it, so you can specify the width in meters or in pixels or in EMs or many different graphical units, either real world or display specific. So the marker, basically the marker are multi-graphic, and so it can contain more than one graphic. So in your marker, for example, you can have a point, image, and then you can have some text that goes together, and all that together is considered a marker. And all the graphics have a position and an opacity. And we have a distinction between marker and label, in that a marker is something that is always placed exactly at the location, whereas a label is something that will go through a label placement engine, and the label will be rendered on top of all the other, is a second pass on top of everything, whereas the marker will really be or rendered in the order that, in the Z order specified, basically. Or the order of the layers. And so one type of, so you can see that a marker is a multi-graphic that contains multiple graphics. And basically there's 4 types of graphics that it can contain: a dot, an image, well, a dot actually is a shape, so it's a shape, an image, or a text. So it's 3 types. I have text in the next slide. So shape, image, and text are the 3 types of basic graphics, but of course the marker itself is also a graphic, so a marker could contain another marker with the more advanced requirements classes. So the dot, basically you can specify the size through the use of a stroke, so you can say a width and a color and opacity. And the image, you can point to a resource. So this could, and the reason using this resource class is trying to support both the offline and online use cases. So it might be local PNG files, it might be a resource online. It might be inside a geo package using a portfolio extension. So there's many different ways you can point to the resources, and this allows you to support all of that. And some of the things we have in the image is the hotspot. So that's where basically where it will be, which point of the image will be at the position specified. You can apply tint and black tint to color either all the colors be multiplied by the tint, or the black color only is replaced by the black tint. And the alpha threshold is to know where you're clicking through the image, or you're clicking on the image for picking purposes. So text, basically, you have the text property, which is what you're going to display. And there's a special clause in there that says that you can, even if you don't support the arbitrary expressions, you can always reference basically the feature properties and have it replaced there, so you can point to some text in your geometry. At the table, we put in your geometry and your feature properties, so you can point to those text features there. And you can specify a font and an alignment. So that's for text. And so this is an example here, styling roads. So by default, visibility is false. If scale denominator is smaller than 200,000, turn the visibility on. Make the stroke gray, 5 pixel, opacity 1. If the scale denominator is smaller than 10,000, then change only the stroke width, but keep the same color and the same opacity to 8 meters, and then set a marker. And so basically the marker contains a single element, that's a dot, which is 10 meter and white. So that's basically showing almost everything that I was showing before. So it's a first. I know it's a lot of content packed in a very short time. I'm happy to engage with any of you here or on the GitHub or by email to explain in more details. So this is the labeling. So basically you have a label which is very similar to the marker in that the label is also a multi-graphic that can contain multiple primitives, and basically they will all get placed together as one entity. And the extra property you have here is the label placement, which at the moment only contains priority, min spacing, and max spacing, but an extension in the future could add more control over the label placement. And another related kind of requirements class is font outline, so you can make the text, basically you can read the text on any map background, so you can specify a size, opacity, and color for the font outline. And so for styling coverages, we have color channels, alpha channels, single channel. So basically color channels is saying you can want to attach this property to red channel, this property to green, this property to alpha channel, but also the blue channel. And a single channel is you just want to map one property. And when you do the single channel, often you want to set the color map, so you can map whatever range of value to specific colors and have an interpolation between those colors. And you can also do the same with the opacity. Now, if you also support the arithmetic expression requirements class, then you can also do band arithmetic with this. So you can point to a single channel and you can plug in an NDVI expression directly in your single channel, and you can apply a color map, and you can style your like the Sentinel-2 data with NDVI. So I think that's everything here. And this is an example here of exactly that. NDVI from Sentinel-2 data. So you can see single channel is B08 minus B04 over B08 plus B04. And then there's a color map that's applied, the values between -1 and 1. And there's also nested rules here. If the scene classification layer is the medium cloud probability, it reduces the alpha channel. If it's high probability, it sets the alpha channel to 0. And you can see there's a layer type check here to make sure it only applies to coverage data layers that have the layer ID Sentinel-2 up to 8. So there's some requirements classes for hill shading. I won't go into detail. And there are several other additional requirements classes that I did not mention, and they are a bit more, which is also something I hope to work on this weekend, which will be on we have an issue open in the repo about functionality that is missing currently, that we want to integrate into the existing requirements classes, or add as new requirements classes if it doesn't fit in the existing ones. So I probably won't go into how much time we have. So do you have time for a question? How much time we have? Sure. So maybe we should start with questions, and I can go into more detail.
How much time do you need?
I don't know how many questions there are. So let's just see. Are there any questions so far? Because I know there's a lot of content. So before, yeah.
Yes. I'm thinking about vendor options. Is it planned to currently you can have vendor option for taking specific option of the implementation? Is there anything like that in the standard?
Vendor options.
Vendor options, yes.
Oh, vendor options.
Yes, sorry.
Well, it's okay. So, the idea here really is it's interoperability. So, vendor options really go against interoperability. But however, this is really meant to be extensible, and there's clear extension points. So the extension points, and then I can go back to my first slide. Here. So there's an extension point basically as maybe this here in the expression. So you can define a new type of expression. If what you want to extend is more on how you select things. So you can extend You can also extend the system identifier expression, so you can define new type of system identifiers. And then finally, the last thing you can do is you can add new properties to the symbolizer. So just like the requirements classes I defined here adds properties to the symbolizer, like the hill shading, for example, adds a hill shading property. New requirements classes can add new extension. So technically these could be vendor options, but the idea is that rather than vendor options, it should be more like community that say, well, we need this functionality, it's not currently there, and we can discuss with them, with the standard working group. And the idea is to do extensions, because all of this really is just part 1 of Styles and Symbology 2.0. So we're foreseeing like a part 2 or 3, and some of them might be really specific for particular domains. So if there's some functionality that is not currently in there, that would fit nicely together as one extension, that's basically what we would suggest to do. But it's not possible to do vendor options because you can still define new type of expressions, you can still define new properties to add to the symbolizer class. That's the 2 extension points basically.
So on the contrary of the current implementation, you won't have something specifically labeled vendor option.
No.
No more.
No, the goal is to try to avoid vendor options and to try and standardize, like, to make it extensible and see it like going forward really, and try to organize them maybe in domains like meteorology or maybe more advanced 3D symbology would be ideas for future parts. And so instead of doing vendor options, let's get the vendors together and standardize what it is they're trying to do. That's kind of the goal. I think that will really help interoperability. And really the idea, like I said, if an encoding fully conformed to the conceptual model, to specific conformance classes of that conceptual model, that style encoding will be fully compatible with any other encoding that supports the same conformance classes. So it's really the true, and it's the transcoder, right? The geostyler implements the conversion from one style to the other. So that conversion should be achievable in a lossless manner if the encoding starts supporting the model that we're suggesting.
I think one of the main problems that SLD is being like quickly replaced with map-up styles and stuff like that. Isn't that because it's too complex? Like, wouldn't it be better to just make a part 1 to be a very simple symbology that's actually easy for the different projects to implement, and then make a part 2 where you like take a bigger range, like the nested styles? I think that would be very, very hard to implement in a lot of the projects here.
So let's talk about that, because if you think it's really, really hard to, I don't think it's very hard. I think it's very easy, and I think it's a huge advantage for cartographers. Because I've seen style sheets that are 50,000 lines, and this really collapses them to way less. It's like the advantage of it is huge, and I think the difficulty is not high because it's easy to flatten it. So let's say if we think that it should not be in the core, it should be a separate requirements class, we could talk about that. But the other aspect you mentioned, so we still have this idea of a core. So the core is, there's quite a bit in the core, but really it's limited. There's some limit to it, but the fact is that cartographic symbology is difficult, it's complex. So we try to really find like the balance to it is the minimum that we can define that's useful. And then we have those basic vector styling, basic coverage. And the idea really is, like initial implementation should really focus on the core and the basic vector or basic coverage for both, and just that. And basically we're hoping for feedback from the community to try to implement this, to see is this too difficult. Because in contrast to the SymCore 1.0, it defined so little that nobody implemented it because basically it's not useful. There's not enough in it to make any useful style sheet. So here we're trying to find the balance. And even though part 1 defines a lot of more advanced functionality, there's a clear distinction of what is core and what is basic vector, basic coverage, and then there's all this other stuff that I showed at the end, which is left as. So this is all the other stuff that basically we're saying, okay, you've done the core, now consider what in here do you want to implement. But if you implement the core, the basic vector and the basic coverage, basically we have that much interoperability. But yeah, feedback as to what is in there currently. If it's too much for implementations and nobody will implement it, we want to know before this becomes a standard. Because the goal is that this should be easy to implement. Because we want it to be easy to convert from existing styles. And so we do implement SLDSC and Mapbox GL styles, and we're doing conversion between them, and we'll work in conversion with this as well. And I know that Mapbox is a bit different. The Mapbox GL, there's kind of a different approach for many things, so sometimes you don't already have a direct match. So I don't think Mapbox GL will conform to the core here, and even the SLDSC might not. But at least we can do a mapping of what is it that you lose and what's the best way that you can convert an existing Mapbox GL style to what can be defined here and vice versa.
Yes.
One question regarding, I'm not sure if this is part of the standard, but are there rules regarding the precedence of rules, which rule applies in which case? Because I can imagine that if you create the selectors, then sometimes features apply to multiple rules, and sometimes we might have or might set the same styling option. Let's say like this, maybe the color. Are there clear rules which rule precedes the other?
In that model, there was a very clear rule, so the later rule overrides. And so basically, the latest rule in your list of rules, let's say in the CSS like here. The very last rule override, and if you add another rule, let's say at the bottom, that would override anything above. So whatever is the latest, and of course inside your nested rule selector, this overrides anything in the parent rule, but also rules that are below will override that. And there's an include directive as well, so that you can include another style sheet, because it's really cascading, so you have the include mechanism as well to do the includes. Thank you very much.
Thank you very much.